So let's look at histograms and polygons in a bit more detail. I mean, they're the two types of graphs we're used to seeing with stats. So the histogram, you remember, is the one that looks like a column graph, but it has some different rules to just ordinary column graphs. So when we draw up our histogram, the score is centered on the column. So you always put whatever the value is in the middle of the column. Those values on a histogram are sometimes called the bins. So you might see that expression. Now, in a histogram, we don't leave a gap between the columns. They join up. So there's an example of our pet example from the last bit. That'd be our frequency histogram. And on the right, I've drawn the cumulative frequency histogram. It's obviously the columns keep getting bigger and bigger in a cumulative one. Okay, the polygon. And the polygon is like the line graph. So the rules for the polygon. You plot the points immediately above the data. So it'll end up being, if you had the histogram there as well, it'll be on the top of the histogram, but in the middle. That'll be where you plot the points. So like so. So I've plotted the points for each of the columns there. But the other thing we do is we start and finish at what would be the next bin or the one prior. So on the right hand side, I join up to where 5 would be. And on the left hand side, it's a bit strange because of course you couldn't get -1 pets, but you would join up to where -1 would be. And there's our polygon. Now for a cumulative frequency one, that one, we start at the corner, the bottom corner of the first column, and then we join it to the opposite vertex. And then we keep joining it to the opposite vertex, and so on. Another name for a cumulative frequency polygon, the ogive. Group data. See, when we're dealing with discrete data, sometimes you group it together, because if you've got a whole heap of discrete data, it's not practical to draw a point for every single possibility. So sometimes we group it into classes, so class intervals. So how do we group it? These are the general rules when we're working out how to group our data. Got to be inclusive and not overlapping. So what do I mean by that? Well, it means that every piece of information could only go into one possible class. There's no way it could overlap and go into two of them and so on. So now what happens for ones that fall on the boundary? It doesn't matter which one you put it in, but whatever decision you make must be consistent. So if it's on, say, the right-hand boundary or the left-hand boundary of the next one, if you decided to put it into the left column for that, then you've got to do that with every one on the boundary, always go in the left. If you decide to put it in the right, then you always put it in the right. And so when you're presenting data, you would make a comment on that. If you did have some data that lied on the boundary, you'd say, well, this is how I dealt with it. How many classes? Well, again, you don't want too many. I mean, that was the whole point of grouping the data. So you didn't have a whole heap of different scores there. So rule of thumb, between 5 and 10 classes. And so then you can work out your interval width by simply, well, the width will equal whatever the range of the data is and divide it by however many intervals you've decided you're going to have. And note, you always round up when you're working out that. Now, when you're doing your calculations to work out the average and things like that, you assume that every score in that group has the value of the centre or the median of that class. So we've got heights of 300 students. And we placed it into 8 classes. Now, I suppose technically height is continuous data, but it's not like we could actually measure your height to, 32 decimal places. So we do think of it as discrete data for the sake of experiments and what have you. But there we go. I've grouped them into 10 centimetre blocks. So we're going to use our distribution table. We're going to find the mean, the median. Well, it now will become a median class, the modal class, the variance, and the deviation. So there's my frequency. The next piece of information we want is fx, but you'll notice for x, I'm using the middle, the class centre. So 125, 135, and so on. Now, to work out the average, because also the other thing to notice here, I'm not using probabilities here. You remember that when we used probabilities, it ended up simply being that the average was the sum of the fx column, because we were playing with probabilities. But I'm not dealing with probabilities here. So in this case, I've got to divide it by the number of scores, because that would end up being the bottom of the probability, if you like. So for R1, I get 156.5. Now fx squared, we want that row, because that's going to help us work out variance and deviation. So it'll be sum of fx squared, but again, I need to divide it by n for this, because I'm not dealing with probabilities, I'm dealing with the actual number of scores or the frequency. And I get 262.75. And so, I don't know if you do recall or not, because it's been a while since we've done the stats topic, but variance, remember, the quick way of doing it was that the fx squared one minus the expected value squared, or the average squared.
X squared minus
yeah.
squared.
So that's what I've done there to work out our deviation squared, or variance. So to work out deviation, we find the square root of the variance. So I've got that one, 16.21. All right, now I've put a cumulative frequency row in there, because we're going to need that one. So I can work out, well, we worked out the mean was 156.5. The median class, there's 300 all up, so I want to know where the 150th, or hang on, it's an even number, so it'll be the average of the 150th and the 151st, won't it? But in our example, they're both in the same class anyway. And that's 155. Well, sorry, the class is 150 to 160. The class centre of that was 155. The modal class is the same one. Remember, we're looking at frequency now, not cumulative frequency. And the biggest one there is 100. Variance we worked out before, 262.75. Deviation we worked out before, 16.21. So there's all the information. You can use the ogive, or the cumulative frequency diagram, to come up with a median rather than a median class. So there's my cumulative frequency histogram. Draw in the polygon. Now, 300, this time I do just divide it exactly by 2. So 150, and it's a matter of reading off the graph. So 150, bang, and I read it off the graph. Now, the answer is not 155. Because now we assume that this is a continuous scale. And go, righto, where would that have fallen? So, if I'm just looking at that piece, right, it was going from 150 to 160. The values went from, where are we? Here he is, 99 to 199 for the height of that. So that's where that part of the ogive's going up. I've come across it where it was 150. We're saying, bang, where do we end up down here? So look, I'm going to use similar figures. You could use coordinate geometry now, I suppose, too, because you could say, well, that's an equation of a line. What's the slope? Come up with an equation for it and work out what it'd be the x value, wouldn't it? You could do it that way. But using similar figures, there's my answer. Now, where did all these numbers come from? Okay, 150, there it is. So we start with 150. Oh, it's a shame. In hindsight, I should have picked a better example where it wasn't also 150. But anyway, we're saying horizontally the difference is going from 150 to 99. That's over 100. Basically coordinate geometry, rise over run. So I know the height changes by 100, but now I multiply it by 10 because that's the width of the class. And I'll end up with 155.1. So that's using similar figures. As I say, you might find it easier just to use coordinate geometry, come up with an equation for the line and go off that. So we can actually come up with a value for the median. When you notice it, it's not far off that class centre as it is, but anyway, it wasn't exactly the class centre. It was 155.1. Alrighty.